Hello and welcome everyone. And once again, thank you very much for taking the time to attend the second installment of the Virtual SAN Take 20 webcast series. My name is Rolandson Rivera and I'm a principal architect in the office of the CTO for the Storage and Availability Business Unit. And for the next 20 minutes or so, I'm going to focus on covering the availability concept and capabilities of Virtual SAN. So let's jump right into it. One of the principal design goals of Virtual SAN was to deliver a solution without any single point of failures from a design perspective that included both hardware and software. In Virtual SAN, data accessibility is at the utmost importance in order to deliver on the promise of mitigating every single point of failure. Now, there are certain availability features and vSphere functionalities that are leveraged within Virtual SAN in order to achieve those particular goals within the solution. Now, Virtual SAN uses the concept of availability zones in the form of failure domains within its distributed architecture in order to contain or reduce the impact of any potential failure that may happen within the system, as well as with any of the services that are being rendered. From a hardware failure perspective, Virtual SAN delivers zero data loss and zero downtime despite of any single or multiple device hardware failures simultaneously or individually. From a software perspective, Virtual SAN allows you to control the availability settings and requirements of an application through a policy framework that provides a level of automation and management that is entirely focused on the virtual machines and their data based on what needs to be done and achieved or in accordance to their requirements. One of the software functions that were implemented in Virtual SAN as part of its availability features is the use of this policy-based management framework. Now, this framework allows Virtual SAN to intelligently place virtual machine objects across different logically or potentially physically defined failure domains, regardless of what they may be. They could potentially be servers, racks, eventually sites, and so on. But this is done in order to enhance the application availability even in the most critical failure scenarios. Virtual SAN has been integrated with key and critical features of the vSphere platform, some of those being vSphere HA as well as its maintenance mode mechanism in order to expand upon the data management capabilities, but also deliver a much better level of data availability as well as accessibility at any point in time. Of course, when it comes to managing the different failures, these things can actually be a little different, whether the failures may be happening with individual storage devices, the different types of devices that are part of that configuration, or potentially even the network. Either way, Virtual SAN has the necessary technologies and features to deliver the highest level of availability to any virtualized application today. And I'll get into some of those details here. Availability in Virtual SAN is delivered or yet defined with the concept of failures to tolerate. This is basically tied into the failure domain concept, which I explained previously. Now, there's a couple of different ways now with the latest release of Virtual SAN, which would allow you to define levels of failures, but also on a particular method, which delivers not just a mix of availability tied with space efficiency or performance. When it comes to Virtual SAN and delivering high availability to virtual machines, even applications, these concepts are defined based on the number of failures to tolerate that can consistently occur within a particular cluster configuration. Now, that definition of failures to tolerate may encompass a host failure, a disk failure, a network failure, or even potentially a storage object that can fail within the actual system. Either way, you can define the actual policy within the system to sustain any particular type of failure as long as it doesn't overpass or exceed the maximum number of failures to tolerate, which is 3. Now, as a result of a number of failures to tolerate, the way in which the system provides availability by default is based on a mirroring sort of methodology. So whenever any given application is deployed onto virtual SAN, automatically it's given the N+1 sort of availability configuration, because in virtual SAN, everything is basically deployed in mirror sets. Now, that particular method of failures to tolerate is based on a performance characteristic, which is the default in which virtual SAN operates and works under. As I mentioned before, virtual SAN also has the ability to deploying and providing high levels of availability with failures to tolerate with a method that is more focused around space efficiency, which requires a larger number of nodes, and then we can distribute the data in different RAID working sets, such as RAID 5 or RAID 6. That's something that I covered previously in the space efficiency webcast, so I will sort of go past that since we're beyond that point. Now, to explain here, whenever it comes down to defining the number of failures to tolerate, as I said before, virtual SAN automatically gives you the N+1 copies of a particular object. So that means that whenever a VM is created, its objects will be deployed in a 2N+1 sort of configuration, as long as a number of hosts are contributing the storage required to satisfy those requirements in terms of data placement. As you can see here, when it comes to the efficient placement that I mentioned before in distributing the data throughout the cluster, here's an illustration of how that system and actually manages and handles these particular functions as it relates to the management of data. Here you can clearly see that while a virtual machine runs on a particular host, the way in which its data is accessed is across the network to components or data sets that have been placed on other hosts and on other disk groups or disk devices within themselves. Particularly here, if a virtual machine was to access its data directly in the host that it is being hosted, that actually lines up to be a single point of failure. Whereas if any device within that particular host fails, can potentially not only bring down the virtual machine, but also suffer a potential data loss. In this particular layout and scenario here, you're looking at how the data is distributed. And in this particular case, in the event of a failure or something going wrong on the host where that virtual machine is actually being hosted, that virtual machine will be able to be brought back up with vSphere HA and get back to accessing its data, and vice versa. If any one of the other servers that are actually hosting or storing data or information for that particular virtual machine and its application, in this particular scenario, any one node or any one device can fail, and still the system will provide and continue to access its objects and components without any potential outage in service or outage in terms of accessing the data. So the virtual SAN availability concepts, which are applied in the sense, as I mentioned before, in the sense of a fault domain, are applied throughout the entire system and is applicable not only to the hardware components, but also to the actual software as well. So let's take a quick look at an actual demonstration on the actual layout of a particular virtual machine so that you can sort of see how this maps as being illustrated here in the function of a real infrastructure. So let's take a look at a system here, one which is pretty largely consumed with a large number of virtual machines, but let's look at one particular virtual machine to identify the layout and the availability settings that have been applied to it. First of all, it's important to identify what I highlighted in the slide before, which here, this virtual machine is hosted on a particular host, which may not be the one where the data is currently being accessed, to obviously avoid that single point of failure, as I mentioned before. When we look at the actual settings and layout for the policy that is applied on the system, as you can see here, number one is the default policy for virtual SAN. And here you can see how that particular VMDK has been deployed in the N+1 method, which I mentioned before. All of its components have been deployed onto different servers, as well as different witness, which is a file that allows us to sort of identify quorum when there's a sort of failure in order to avoid split brain behaviors. But either way, you can very quickly see here how the logic in virtual SAN from an availability standpoint is applied on the hardware as well as the software itself. And as you saw there, those are pretty useful implementation methods from a software and a hardware perspective. Now, one thing that's always really important to understand is that in order for virtual SAN to always deliver access to data, depending on the actual failure or when it comes to bringing back up these virtual machines to continue with their service or the services that are being rendered, the logic that is implied within the system is that at any point in time, the system should have access to a greater capacity than 50% of the data that is being deployed throughout the system. So as long as you have access to one full replica of the data that's been deployed and the witness file, which is a component that it's designed to, as I mentioned before, serve as a quorum in the event of a failure, so that we can actually bring back that virtual machine and that application with vSphere HA and continue to function and operate in its normal functions and features. And now let's expand upon the concept of failures and move on beyond the single cluster failure identification and expand a little bit about failures across fault domains, which in virtual SAN, we're able to do that today by increasing the concept of availability through introducing a level of awareness into the system, which allows it to behave in a particular fashion. Now, for example, a particular ESX host is what we consider as a fault domain, right? Now, virtual SAN, even though it acts and it behaves with this sort of logical concept of failure domains, we are also able to introduce fault domains as a feature to the platform in order to increase or introduce a level of awareness which can be carried out across or beyond just the concept of a cluster or beyond the concept of a host, and now introduce availability awareness across potential different failure domains that are represented in the form of rack failures or even site failures. So let's take a look at, for example, some of the layouts that happen, particularly when we introduce fault domains as a feature. So for example, whenever we try to create or define fault domains logically within virtual SAN, this allows us to sort of protect against rack failures, which are very commonly required in large infrastructure designs and architectures, but also it allows us to protect against potential top of rack switch failures or even power failures that may happen within a particular rack. It's important to understand that as long as you are able to satisfy the connectivity requirements from a network perspective for virtual SAN, you could potentially define availability zones or failure domains that are constituted based on racks or even potentially on-campus buildings. Overall, conceptually, what we're doing here when we're trying to define failure domains in the concept of the feature that's part of virtual SAN is that we are allowing the combination of multiple hosts to now be combined into a single failure domain. Now, what does that do for you is that essentially allows you to sort of aggregate multiple hosts into different racks, building sites, and allow you to sort of eliminate or guarantee that no single replica, no two replicas in a witness of a potential file will be placed on the same fault domain in order to then mitigate the concept of single failure that we have been discussing so far. So in this particular case here, we have to treat failure domains in the same fashion or the same way in which we consider or treat the configuration of a virtual SAN cluster. So in concept, if you think about fault domains as the configuration feature that you see here, and you compare it to what virtual SAN requires to successfully form a cluster, is a minimum of 3 nodes, which is translated basically to 3 fault domains. So whenever you're going to deploy a cluster across this particular architecture, you apply the same concepts, which means that at a very minimum, if you were going to form a virtual SAN cluster in a fault domain that is consisted of racks, right, you will need a very minimum of 3 racks to successfully form that cluster. Whether it might be each rack populated with a single node or however many nodes you need to populate it to satisfy the requirements of your cluster size. But either way, this is the concept that needs to be applied when it comes to delivering that sort of level of availability. Now, as I mentioned briefly before, what this is going to guarantee is that you will, one, potentially get much better space efficiency results by deploying the system in this format, where it's going to guarantee that no two objects will be placed on the same fault domain in order to obviously avoid a particular failure. And when I say no two objects, it means the replica of an object will not be placed on any one of those particular fault domains where the potential parent of that data currently resides. So let's take a quick look at an example of how that's actually laid out and how the fault domains are configured and enabled within virtual SAN in order to deliver and expand upon the level of availability within the solution. So let's take a look at this environment here where currently this environment is configured in a single cluster where each host is acting as its own fault domain. As you can see here from the fault domains and stretch cluster menu within virtual SAN, we're highlighting that specific concept right now. Now, what I'm going to do is that I'm going to configure logically, I'm going to map the placement of each one of these hosts onto a particular rack, and then we're going to identify and take a look at the actual layout of the virtual machine's data as it pertains to the availability requirements that have been placed on a particular VM storage policy. Here you can see that very quickly we can define these failure domains in the sense of racks by very quickly creating a label and assigning a number of hosts which will be part of that particular failure domain. This is the sort of logic and the function that's going to force the system into behaving in a way that it will not place replica objects on the same failure domains where one of the copies of that particular data is currently residing, which is then guaranteeing that level of availability. So here now I've defined all 4 fault domains. You'll see successfully here after the refresh where all 4 racks are now populated by 2 individual hosts. Obviously, there is a number of virtual machines that are actually already running on the system, and they are currently consuming the default policy. So now let's see what happens and how the data is laid out in the terms of availability. So here we're looking at this particular virtual machine, which it happens to be hosted on host 11, which seems to be part of the failure domain B, which is in this case rack B. So now let's take a look at how the data is laid out. So number 1, the virtual machine is hosted on rack B, as I mentioned before, but you can take a look at here how the actual replicas, the witness, and the actual data is laid out onto different fault domains entirely, which actually in this case guarantee the point of availability and accessibility, which is what we're trying to highlight particularly here. There are a lot of interesting concepts which are applied here as part of the availability features of virtual SAN. And I have to say that one of the ones that need to be pretty well understood is how virtual SAN utilizes the concept of fault domain and also how it applies the feature fault domains in this particular model and approach, because it would make things a lot clearer and things would be understood more efficiently in the terms of data accessibility and availability whenever it comes to the definition of fault domains or the definition of failures to tolerate depending on a particular requirement. One other aspect of the high levels of availability delivered with virtual SAN have to do with covering what goes on the network. So one of the things that I initially mentioned when we started the webcast is that virtual SAN, from an availability standpoint, is able to cover more than just the components that are part of the host themselves, right? One of those components now in this particular case happens to be the physical network. And how is virtual SAN designed and geared to address potential network failures? Well, here is a particular scenario which can occur depending on different types of failures that may occur in the network due to multiple types or different failures when it comes to the inability to communicate over the same network. Particularly here, we're looking at a situation where the network becomes partitioned and the hosts that are part of the cluster are no longer able to communicate between one another. And in this particular case here, you can see how two out of the four hosts are no longer able to communicate, and because of that, they end up being in what we call a network partition. And virtual SAN, when you look at the way the cluster is formed, typically they form their level of communication across a particular network group, which is identified within the user interface of the virtual SAN cluster management tab. But here in this particular scenario, what happens is that two of the nodes have been made sort of isolated. One of those nodes is hosting the actual virtual machine. Another one has one portion of the data or one entire working set or replica of that particular data from that virtual machine. The other two hosts, one of them is hosting the replica and the other one is then hosting the witness object. Now, obviously, what's being done here is that we're able to power down the virtual machine as it is obvious that it's lost access to 50% or greater of the components that it needs to be able to access in order to sustain accessibility and availability within the system. Now, because virtual SAN has been tightly integrated with vSphere HA, we're able to identify the fact that there's no actual suitable or compliant level of communication between the nodes within the system and also the virtual machines accessing their objects. Here, what will happen is that HA will then shut down or power down that virtual machine and can potentially bring it up automatically on any of the other two hosts, which now have access to a greater percentage of the data, which meets the requirements in order for the virtual machine to come up and for the system to actually access the data, which is always what I've said before. In order to maintain accessibility and availability for the data in all the virtual machines, we need to have greater than 50% of the components and the data in order to achieve this. And here clearly you can see how there's one full replica on one host and the witness objects that place a quorum on another host. Both of those hosts are part of the same network partition, and at that point in time, that's why HA will be able to automatically bring up that virtual machine and then deliver the level of availability and accessibility that is expected in that particular configuration. When it comes to the enterprise, it's very important to be able to satisfy and meet the requirements of what we call enterprise class availability. For the most part, most customers and just about everywhere in the world, folks tend to be pretty affinitized to the whole 6 nines availability. And in virtual SAN, we don't really calculate the levels of availability in the sense of number of nines, but they can be very clearly mapped to the same concept. Now, in virtual SAN, the levels of availability are mapped based on some of the things we've discussed, which are focused around the number of consecutive failures to tolerate within the actual system. That obviously can be constituted in the form of a device failure ranging from a storage device, a storage controller, a network interface, the motherboard, the host, you name it. Either way, we have the way and the ability to map any one of those potential failures to still yet be able to deliver a level of availability to virtual machines and applications that is equivalent to 6 nines. Now, the way in which we do that, which is also pretty nice and it's simplified in a lot of ways, is that we have the ability to define a consecutive number of failures to tolerate in the range of 2. So far, some of the demonstrations I performed and showed you today were based around a single failures to tolerate. But if you want to be able to satisfy the requirements of a 6.9 availability, you can essentially build or configure a policy that delivers failures to tolerate equals to 2. That essentially maps to the same level of availability most of the enterprise customers are demanding with regards to their applications and their infrastructures. One of the things that is pretty unique about virtual SAN is not only is this a way to deliver availability in a much more manageable and also more affordable way when compared to traditional infrastructures, but if there was ever the need to change the availability requirements where they have to either be increased by one more or reduced by one, this sort of thing can be done by simply changing a policy on any given virtual machine and again applying it. And within minutes, depending on the changes, the distance, the amount of data, and the requirements that are needed to either be increased or decreased to satisfy the levels of availability, those requirements will be quickly satisfied within the system and the infrastructure. So when it comes to the definition of enterprise class availability, virtual SAN falls absolutely no short of one of the better solutions that are out there by being able to deliver that level of availability at a much more affordable solution standpoint and also at a much more manageable approach. And to continue with enterprise availability, one of the capabilities of virtual SAN now is the fact that it's able to deliver site protection availability. Now with virtual SAN, you are able to deploy a cluster that can span multiple data centers and be used in an active in the form of business continuity. Overall, there's a lot of capabilities and a lot of functions that make virtual SAN a suitable product and a suitable solution to deliver at the highest level of availability for any enterprise. So let's take a quick look at a demonstration of a stretch cluster configuration and see how it reacts and the impact to the virtual machines and their application when we introduce a complete site failure. So let's take a look at a demonstration of a virtual SAN stretch cluster deployment and what happens when we introduce a complete site failure. This will provide some context into some of the things that we've been discussing. Obviously here, we've actually have introduced the failure to the environment. You can see that virtual machines were functioning and operating as normal before. Here you can now clearly see that a half of the nodes of that particular cluster are now offline, and so are the virtual machines that were running and operating in that particular system. And you can see them being listed and highlighted as disconnected. Now, keep in mind that within a very short time, as I go here and refresh the user interface, you can see that the virtual machines have been brought back up online by your HA and are actively somewhat in the process of coming right back up. Now, one of the things to identify here also is the fact that the virtual machines policy is highlighted as non-compliant. Why is it non-compliant? Well, in order to be compliant, all of the requirements need to be satisfied by that particular policy for that virtual machine. And here you can see that all of the disks are non-compliant. Now, the reason for that is obviously because we're not able to access all of the data components across the two sites. Here, you can actually see that one of the components, which is basically one of the replicas, which is placed on the site that just went offline, is no longer accessible by that particular virtual machine. And you can expect the same behavior of all the other virtual machines. Now, that will be rectified and will be back into full compliance once the other site becomes active again. Communication is then probably reestablished and the system can then synchronize. And at that point in time, virtual SAN will bring back everything into full compliance into what we call its self-healing sort of mechanism. So that about wraps it up for me today here, folks. In the event you want to get more information and learn about virtual SAN, there are a lot of things out there that you can use. You can actually contact your VMware partner and join potentially a virtual SAN assessment project. You can also learn about virtual SAN by trying some of our hands-on labs, which are available online. And if you're ever looking into a virtual SAN solution, there are many ways in which you can actually get virtual SAN into your infrastructures, whether it be in the form of an engineered appliance or a virtual SAN ready node. Either way, lots of options for you to deal with and lots of things you can do and actually achieve your goals with virtual SAN. So with that, I'd like to thank everyone again for taking the time and attending the second installment of this Virtual SAN Take 20 webcast series. My name is Roland Rivera, and hopefully I will see you soon again on another episode of Virtual SAN Take 20. Thank you.